In this video, we demonstrate how to encrypt and decrypt with the additive and multiplicative ciphers using Mathematica. While many of these computations can be done with a handheld calculator, Mathematica makes the process much smoother and more efficient. We will make use of several shortcuts, including computing with entire lists of numbers and using the percent sign for the last output. For our first example, we will encrypt the word battle using an additive cipher with a key of 19. To begin with, we need to convert the plain text to numbers. This is done with the toNumbers command. We need to enter the plain text as a string, keeping in mind that case is unimportant. This outputs a list of numerical values. To each of these, we need to add 19. Rather than do each addition individually, we can add 19 to the entire list in one step. To do so, copy the list and simply write add 19, and Mathematica does the computation for us. Now we need to reduce these values mod 26. Any value that is larger than 26 has to have 26 subtracted from it to get it back between the range of 0 to 25. This is done with the mod command. Once again, mod can work with an entire list of numbers, so rather than doing it one at a time, we can copy the entire list, except put it in the right place, enter the modulus, and that will give us the reduced values. Now we need to convert it back to letters. To do this, we use the toLetters command. And again, we can feed it the entire list. And that gets us our ciphertext. For our next example, we decrypt the following ciphertext, assuming an additive cipher with a key of 23. This time, as we go through the computations, rather than recopying the list from the previous output, we will use the percent sign to accelerate the process. Just as before, we need to start by converting to numbers using the toNumbers command. We enter the ciphertext as a string, and that will give us the result. Alright, now, since we're decrypting, we need to subtract 23, so we take the previous output, this time we use the percent sign, and I subtract 23, and that will subtract 23 from every value in the list. Now we need to reduce it mod 26, so this time anything that's outside of the range we're going to need to add 26 to it. So again, using the last output, I tell it to reduce it mod 26, which gives me that list of numbers, and from there I use the toLetters command again to that last output, and it will give me the resulting plain text. For our third example, we will encrypt blind using a multiplicative cipher, now with a key value of 15. The steps are essentially the same, except we will multiply rather than add. So once again, we convert to numbers, entering the text as a string. We take those numbers, we multiply them by our key value, we reduce every value mod 26. Now with multiplying, we'd have to subtract 26 multiple times. This will greatly accelerate the procedure. And then lastly, convert that back to letters, and we get our ciphertext. The fourth example involves decryption. Here we're given the encryption key, which has a value of 5. As a first step, we're going to need to multiply by the multiplicative inverse of 5 mod 26. To find the multiplicative inverse, we use the command powermod. Powermod is meant to compute arbitrary powers using modular arithmetic. In order to figure out an inverse, we use the fact that we want to take 5, and the inverse is the negative first power, and then we give it the modulus. This tells us that the value we need to multiply by now is 21. Otherwise, again, the steps are exactly the same. We convert to numbers, take that list of numbers, we multiply it by 21, we reduce that result, mod 26, and then convert back to letters. And that's how it's done using Mathematica.